Hi everybody, in this lesson I'm going to teach you how to rationalize the denominator. Okay, so in order to simplify radical expressions, we said you cannot leave a radical in the denominator. So look at this example. Let's say we have the square root of 5 over the square root of 3n. So there's nothing I can do to simplify that gets rid of that radical. So instead, what I'm going to do is multiply by the square root of 3n over the square root of 3n. Because right now, the square root of 3n looks like it's an irrational number. So we want to rationalize the denominator. Turn the denominator into a rational number. So now, multiplying root 5 times root 3n is root 15n. And root 3n times root 3n is just 3n. So that's one, and that I cannot simplify any farther, and it is in simplest form. Here's another example. How about, watch this one, 1 over root 5. So now we multiply by root 5 over root 5. So we get root 5 over 5. So 1 divided by the square root of 5 is equal to the square root of 5 divided by 5. How about this one? Root 10 over root 3. Multiply by root 3 over root 3, and you get root 30 over 3. Okay? Let me show you one more. Let's say it's written this way. 2y to the second over 3. So what I'm going to do here is separate it into 2y squared over root 3. Now I'll simplify because this is a perfect square and must come out. So y root 2 over root 3. Then rationalize the denominator, and I have y root 6 over 3. Okay? So that's how you rationalize the denominator when the radical expressions are in this form here. The last thing I want to show you is using a conjugate. So let's say we have this one, 7 over 2 minus root 3. So here's what a conjugate is. And this relates to the connection I'd like you to make is to the difference of two squares. So we know that a plus b times a minus b equals a squared minus b squared. So I'm going to multiply by 2 plus root 3. So the numerator just becomes 14 plus 7 root 3. Right? It's like the distributive property, 7 times 2, 7 times root 3. And the denominator becomes, I have to do FOIL. So first times first is 4, 2 times 2. Outside times outside, that's positive 2 root 3. Inside, that's negative 2 root 3. And then last, that's negative 3. Because negative root 3 times positive root 3 is negative root 9, which is negative 3. Then when we combine like terms, those cancel. So I'm left with 4 minus 3, which is 1. So in simplest form, it's just 14 plus 7 times the square root of 3. Using a conjugate to rationalizing the denominator. Let me show you another one of those. How about 8 over 1 plus the square root of 3? So in this case, the conjugate is 1 minus root 3. Minus root 3. Because it's plus here, it's minus here. So when I multiply the numerator, I'll leave it unmultiplied to show you what it looks like. Here, first times first, outer, outer, inner, inner, last, last. So simplifying, that's 8 minus 8 root 3 over 1 minus 3 is negative 2. This is kind of a tough one. So now if I look at it this way, 8 minus 8 over negative root 2 minus 8 root 3 over negative 2. So this becomes negative 4 plus 4 root 3. Okay, I want to show you one more of those. Okay, let's say we have this one. 12 over root 2 plus root 7. Again, multiply by the conjugate to rationalize the denominator. So since it's root 2 plus root 7, I use root 2 minus root 7. So the numerator is 12, root 2 minus root 7. And this becomes, first times first is 2. Outside times outside is negative root 14. Inside is positive root 14. And last times last is negative 7. So I end up with 2 minus 7, which is negative 5. So what I'm going to do in this one is put the negative sign in front, like we always do, and distribute. 12 root 2 minus 12 root 7 over 5. Instead of negative 5, I just put the negative sign there. Okay, so that is how you rationalize the denominator using conjugates. If it's a plus b in the denominator, you multiply by a minus b. If it's a minus b, you multiply by a plus b, because anytime you multiply these two together, you end up with a squared minus b squared, which gets rid of, in this case, it gets rid of that radical. Okay, good luck.